Every Linux server is a fire hose. Syslog, auth.logs, kernel buffers, application daemons, they all scream simultaneously, and you, the sysadmin, are drowning in raw text waves that never stop coming. Scrolling and tail are great for watching the present, but they are blind to the past. Recurring issues, the ones that actually matter, are distributed across thousands of lines, and a tiny bug hiding in a mountain of text will never be found by reading linearly. The fix is a 4-step recipe, and once you know it, you never forget it. Filter the lines you care about, extract the key that identifies them, count how often each key appears, and sort the results so the loudest signals float to the top. That is the entire game. Before you count, normalize the key, collapse near duplicates into one bucket or your tallies lie. SSHD. Failed password for root from 10.0.0.5, and SSHD. Failed password for admin from 10.0.0.5 are the same event with a different username, and counting them separately splits one signal into two noise. This is also a security lens. The same pipeline that surfaces a misbehaving service also surfaces an attacker. Hundreds of failed SSH attempts from the same subnet, or a sudden spike of HTTP 500s. Both become obvious the moment you rank by frequency. Recap, drown less, count more. The recipe is grep for what matters, auth to carve out the key, sort in uniq, c to tally, and sort, nr to rank. In the hands-on demo we will run it against the real /var/log/syslog, and watch the noise turn into a ranked top 10. We'll analyze /var/log/syslog using a 4-step recipe. Filter with grep, extract a key field with auth, count occurrences with sort and uniq, then rank with sort, nr. By the end, you'll know exactly which program is generating the most errors on this system. First, clear the screen and list the contents of /var/log/ to confirm syslog is present. This file is the system's general-purpose log where most services dump their messages, making it the ideal target for error analysis. Step 1. Filter. We use grep error to pull every line containing error in any case, then pipe through head -5 to preview just the first 5 matches. This confirms our filter works before we scale up the analysis. Now let's quantify the problem. Piping the same grep into WC counts the total number of error lines. A large number here tells you how noisy the system is, and whether the problem is widespread or isolated. Step 2. Extract a normalized key. The 5th field in a syslog line is the program or service that emitted the message, so we pipe the filtered lines into auth print $5 to isolate just that field. This gives us a clean stream of program names we can group together. Step 3. Count. We pipe that stream into sort to group identical program names together, then into uniq, c to count how many times each one appears. The output is a clean list of programs alongside their error counts, but it's not ranked yet. Step 4. Rank. Adding a final sort. nr sorts numerically in reverse, so the highest count floats to the top. Here Network Manager dominates with 47 errors, followed by systemd and cron. That's your answer. The top recurring errors ranked. Your baseline incantation, grep error, catches the obvious but misses the rest of the failure vocabulary. Power it up with extended regex and a synonym roster. Grep, error warn failed denied invalid. The flag turns on alternation so the pipe operator becomes a logical or across every failure flavor in your logs. Knowing what's failing only gets you halfway. You also need to know when. Awk, a print $1, $2, $3, $5, pulls the month, day, timestamp, and the key message field out of each line. Now a flat count turns into a timeline you can correlate with deploys, traffic spikes, and attack waves. Before you count anything, normalize the noise. Trailing punctuation. Process PIDs like SSHD 1234:, and hex addresses all fragment what is logically the same error into separate buckets. Strip those tokens first or sort uniq. C will dutifully count SSHD 1234. Failed and SSHD 5678. Failed as 2 different problems. Once the pipeline works, promote it from a one-shot to a reusable tool. A quick awk a print $1. Slices logs on the colon-space delimiter to extract just the error category. For repeated use, wrap the whole chain in a bash loop and save it as analyze-errors.sh. Suddenly you have a personal log analysis spellbook you can cast on any log. Now read the sorted output like a security dashboard. If the top of the list is dominated by SSHD, 403, or invalid user, you are under brute force right now. Confirm it fast with a targeted follow-up. Grep, failed password /var/log/auth.log awk, a print $9, sort uniq, c sort in our head. That chain prints the offending usernames, sorted by attempt count. Ready for action. Memorize the order and you can analyze any log anytime. Filter what matters, extract the fields you need, count the duplicates, then sort to see the winners. Filter, extract, count, sort, in that order every time. We begin by clearing the terminal and inspecting what's available in /var/log/, because any analysis pipeline is only as good as the files you pointed at. Listing the directory confirms syslog and auth.log are present. The two targets we'll use to count errors and detect brute force attempts. We start narrow. Pull just the first 5 lines that contain error, so we can eyeball what the entries actually look like before we commit to a counting strategy. Now we count them. The WC_L gives us a raw total, but notice it matches the literal string error. So entries written as error or error all get caught. That's useful, but it's only a single number. It tells us nothing about which subsystem is failing. Field 5 in a syslog line is traditionally the process or component name. That's the column we want to group by. Awk, a print $5, extracts just that field, and head previews the first 10 so we can sanity check the extraction before we sort. Now we normalize. Sort groups identical field 5s together, then uniq, C prefixes each group with its frequency. This is the pivot that turns how many errors into which component is failing most. The PIDs like 882 and trailing colons mean each variant counts separately. We'll address that in the next scene. One more pass. Pipe that result through sort, NR and head, and now we have a ranked leaderboard, the noisiest components at the top. This is the final shape of our pipeline. Extract the component field, normalize by sorting and deduplicating, then sort numerically in reverse. From here we persist it as a script and reuse it on auth.log. The pipeline proven, we harden it. Wrap it in a script at /analyze-errors.sh, so any log can be analyzed with one command, and broaden the regex beyond the literal word, error, to catch variants like error, fail, and failed. This is where the recipe becomes a tool. Finally, we point the same recipe at auth.log. Because auth.log also has 5 whitespace separated fields with the process in column 5, the pipeline ports directly. A spike of repeated SSHD entries for a single source IP is exactly the signature of a brute force attempt, surfaced by the very same sort uniq, C sort, NR pattern.